Hello students, in this video I will go through the steps to partitioning a line segment into multiple equal segments using only compass and straight edge. Alright, let's take a look. So what we're going to do is on a blank sheet of paper, you're going to draw yourself a given line segment to partition. So it doesn't matter what length it is, you don't have to measure anything out. We just need to draw a line long enough where we can perform this task. Okay, so what I want to do with this, okay, is I want to partition this line not in multiples of 2, because that's easy. I know you guys can make the intellectual leap to doing that. Let's say if I wanted to partition this line into 2 equal parts, that's just the perpendicular bisector. We can just break that up into 2 equal parts. Let's say if I wanted to break it into 4 equal parts, well, that would be the perpendicular bisector of the half segment that we've just bisected, right? So we're gonna have to do the perpendicular bisector one more time. So essentially it's doing it twice, and then we can copy the segments, and we can have 4 equal segments. But what about in the situation where we are trying to break a line segment into multiples of, or factors of 3, right? Multiples of 3, what am I saying? Multiples of 3. So let's say if I want to break it up into 3, or into some other odd number of multiples, like 5 or 7 or 9, what do we do in that case? Well, as it turns out, the principle is very, very similar to the things that we've studied in class. Everything ties back to what we studied in class. So what we had studied in class involving similar triangles is, there are all sorts of different properties that all the side ratios are preserved, right, between a dilated triangle versus one versus the original. So what we're going to do is we're going to apply properties of similarities to breaking up a line segment into multiple parts. At first, it may not seem like those two things are even related. Well, that's just the thing in math and with science. Sometimes things that appear to be unrelated are actually very, very much connected. All right, so to first start off, I'm going to take this line segment, and I want to call this line segment here A and B, just so that I can work with it, and then if I need to communicate with you guys, what I'm doing here, that'll be easier later on. And what I'm going to do is, and this may seem very out of left field here, I'm going to draw a line starting from A going outwards. Why am I doing this? Well, that's because my goal is to be able to apply principles of similar triangles. What I'm going to do is I'm going to construct a triangle out of this in a moment. I want to take my compass. I want to break this line segment up into multiples of 3. And this method works for multiples of 3, multiples of 5, even multiples. It could be half, fourths, eighths, doesn't matter. What you're going to do is you're going to take your compass, you're going to open it up to some setting, like I have here. Don't make it too wide, because you're going to be drawing a line segment of this length 3 times on this line segment. I'll explain in a moment. Just follow my lead here. You're going to take this compass, open it up to any setting you'd like, not too big though. You're going to place it on point A, and then we're going to mark that line like so, and then I'm going to pick up my compass with the same setting, unchanged. You're going to place your pin on this point right there. Again, do not change the compass setting. And I am going to draw again another arc. And one more time, you're going to pick up your compass. Do not change the setting. And one more time, the pin on the point of intersection. And we, one more time, draw this again. Do not change the compass setting. So what I have now is the line segment broken up into 3 equal parts. And again, at first it may seem totally unrelated, but I take the last point of intersection that I drew, and what I'm going to do is I will draw myself a line connecting that last point there to point B. So what I've done, okay, is I have one triangle drawn in. You may be saying to yourself, Mr. Chan, this is like creating more work than needed. Trust me. So right now, I have this one giant triangle, right? Remember from class, if we apply the side splitter theorem, if I break this line segment up into thirds like this, and if I draw parallel lines from these points of intersections, hitting line AB, projecting it onto line AB, what would happen to line AB? Based on the side splitter theorem, line AB would be broken up in the same number of multiples. That's the trick right there. One more time. If this line segment is broken up into thirds, and if I draw parallel lines from these intersections hitting line AB, projecting it onto line AB will be broken up into thirds as well. Alright, so what we're going to do then is we're going to construct lines that are parallel to this line. How are we going to do that? So remember in the last video, or not in the last video, in another video, I showed you the construction for making, drawing a line passing through a point parallel to a given line, and the way in which I approached constructing that parallel line in that video is by constructing alternate interior angles being congruent. You don't have to use alternate interior angles. You can use corresponding angles, which is what I'm going to apply here in this video. So what I'm going to do is I'm going to copy this angle here, and then I'm going to place that angle over here so that the angles are going to be corresponding. And if the angles are corresponding and they're congruent, and I draw that line, the line that I draw here will be congruent to this. And that's the theory. Alright, so I'm going to take my compass, which I have not changed. Remember, this still measures that opening. This is still breaking that line segment into thirds, right? With that same compass setting, I have not changed it. If you changed it, you got to bring it back. You got to measure it one more time, okay? Measure that segment again one more time. And what you're going to do is I'm going to copy this angle by doing this. I'm going to draw an arc and hit this line over here. Okay? And what I'm going to do is I'm going to take my compass now, and with each one of these, okay, I will again draw myself that arc. So I'm going to place my pin here, and I will draw an arc like so. I want to do the same thing with this point right here. I want to draw my arc like so. Remember, all of these are of the same length right now, right? And then what I'm going to do next is I am going to take my compass and I'm going to measure the distance from this point of intersection to that point right there. So I measure that. I pick up my compass setting. No, I pick up my compass, not changing any of the setting, okay? And what I'm going to do, okay, is I'm going to take my pen and not place it here, but I'm going to place it here. Why? Because I want to figure out how far away or what that opening is, right, of the angle, of the corresponding angle. So by doing this, okay, again, if I measure this one more time, that's that opening, right? I pick it up, I do the same thing over here. I pick it up, I place my pin on A, and I make my mark like right there. So you can see that the point, the intersection that I've made with the markings that I made on the original ray. If I connect them, that line will now be parallel to that line that I made earlier. So that's what I'm going to do. I am going to take this now, and I will draw myself that line, and I'm going to extend it purposefully to hit line segment AB. And I'm going to do this one more time. Place this over here, and I will draw that line. And there you have it. Line segment AB has now been broken up into thirds. So again, this method works for not just thirds, but for fifths, for sevenths, for halves, for fourths, for sixths, any method. One more time to summarize, how did we get to this conclusion here? We first start off with a given line segment. We draw a line segment. We break the new line segment into however many portions we want, and then from there we construct similar triangles. That's the principle. That's the idea. And again, pause and replay this video if this doesn't make sense first time around, just because the concept here is rather abstract. Thank you for reviewing.